Hello, my dear friends. A very good afternoon to all of you. Welcome to Online Ventures by Exampur. I am Zubair Hesani, and today we are going to discuss a very important topic of physics. And the topic is refraction of light. So let me see how many of you are live. Can we have the responses, please? Please respond fast. I am waiting for your responses, guys. So before going to start the session, let's talk about importance of science in CDS exam. As you all know that science plays an important role in CDS exam. When we talk about the CDS exam, about 30 questions come from this particular section. Out of these, 10 questions come from physics, 10 questions from chemistry, and 10 questions from biology. As far as physics is concerned, most of the questions of physics come from optics. You must have seen in CDS exam held on 14th of November, 10 questions have been asked from physics. 3 out of 10 questions come from this particular topic, that is optics. So keeping this in mind, today we are going to discuss a very important topic of optics, and the topic is refraction of light. Refraction of light, my dear friends. Okay, and this is English medium batch. वो बच्चे जो हिंदी में कंफर्टेबल नहीं हैं, स्पेशली फॉर साउथ इंडियन स्टूडेंट्स, ये बैच लॉन्च किया गया है. तो इसमें कभी कभी हम हिंदी में भी बातें करेंगे, लेकिन ज़्यादातर जो हमारा डिस्कशन होने वाला है वो इंग्लिश में होगा, क्योंकि हम उन स्टूडेंट्स को टारगेट कर रहे हैं जो हिंदी में कंफर्टेबल नहीं हैं. सो प्लीज़ ज्वाइन द सेशन एज सुन एज पॉसिबल, and those who are live, mark your presence in the chat box, my dear friends. So first of all, we will define refraction of light. What is refraction? Tell me. Can you tell me the definition of refraction of light? What is refraction? Now we have Riyadra Adarsh Pallavi. Welcome to the session. And Jai Hind to all of you, my dear friends. So what is the refraction of light? What is refraction? Tell me. So if you talk about the refraction, I am going to define the refraction. When a light ray goes from one medium to another medium, it deviates from its path. This phenomenon is known as refraction of light. In other words, you can say that bending of light when it goes from one medium to another medium is known as refraction of light. So here we have the definition. Okay, here we have the definition. What is refraction? The bending of light when it goes from one medium to another medium. Okay. So when a light ray goes from one medium to another medium, it deviates from its path. This is known as, or you can say this phenomenon is known as refraction of light. So before going to discuss the basic cause of refraction, let's talk about our upcoming batches, guys. Our upcoming batches, my dear friends. So here we have the batches. We have Aspire CDS 122, a complete foundation batch. This course is bilingual. ये bilingual batch हमारा होगा. And here we have the features of this course. इस कोर्स में आपको मिलेंगे 250 plus PDF, doubt session, 350 plus live classes, complete book. Okay, and practice questions. More than 5,000 plus practice questions. Okay, and same course we have in English medium with same features. The course price is 3,999, but offer price is 3,499. Now, the next is Aspire CDS OTA 2022. This course is in bilingual and course features are PDF 200 प्लस PDF डॉट सेशन, लाइव क्लासेस आपको दी जाएंगी, कंप्लीट बुक दी जाएंगी, प्रैक्टिस के लिए क्वेश्चंस दिए जाएंगे. एंड हेयर वी हैव द सेम कोर्स इन इंग्लिश मीडियम आल्सो विद सेम फीचर्स. ओके, नाउ द नेक्स्ट इज एक्सपीडिशन CAPF 2022. This is also a complete foundation batch for paper 1 and 2 in bilingual, and here we have the course features. The course price is 3499 and same course is available in English medium also with same features. Okay, and if you want to get additional 10% discount, use this code special 10. This is the code. Okay, so what is refraction? Refraction is bending of light when it goes from one medium to another medium. Now tell me, what is the basic cause of refraction? This question has been asked in CDS exam a lot of time. Tell me, what is the basic cause of refraction? Tell me. Adarsh. Bending of light due to change in speed. Yes, Adarsh is saying, what is the basic cause of refraction? When a light ray goes from one medium to another medium, speed of light changes. This is the basic cause of refraction. This is very important. So this is the cause of refraction. When a light ray goes from one medium to another medium, velocity of light changes. This is the basic cause of refraction. This is very important point. Okay. For example, let me explain with the help of a diagram. Suppose this is a glass slab which is placed in air, and this is the first medium, and first medium is air, and this is the second medium which is glass. Okay, and suppose light ray travels from air to glass. Tell me the speed of light in air or vacuum. Tell me the speed of light in air or vacuum. 3 into 10 to the power 8 meter per second. Can you tell me the speed of light in glass? So, speed of light in glass is 2 into 10 to the power 8 meter per second. Okay. 2 into 10 to the power 8 meter per second. So, when a light ray goes from air to glass, its speed decreases. That's why light ray will bend towards the normal, because it will travel a less distance. Okay, so just remember, what is the cause of refraction? A speed of light changes when it goes from one medium to another medium. This is the basic cause of refraction. Now, when we talk about the phenomenon of refraction, this is called incident ray. This is your incident ray, and this is the normal on the surface of glass slab, and this ray of light deviates when it goes from air to glass. So this ray of light, and you all know that bending of light ray when it goes from one medium to another medium is called what? Refraction of light. So this will be your refracted ray. Okay. So this is called refracted ray. So this is the incident ray, this is the normal on the surface of glass slab, and this is your refracted ray. And this ray is known as emergent ray. Okay. Very important. Emergent ray. Emergent ray. Angle between incident ray and normal is usually denoted by I. And this is known as, tell me, this angle is known as what? Angle of incidence. Okay. And this is the normal, and this is your refracted ray. An angle between normal and refracted ray is usually denoted by R, and this is your angle of refraction. Angle of refraction. Okay. And this is your emergent ray, and this is the normal on this surface of glass slab, and this angle is denoted by E, and this is your emergent ray, and this is your refraction of light. This diagram is showing refraction of light. I hope it is clear to all of you. Clear? If clear, please comment. If you have still any doubt, you can ask, please. So this is your refraction of light. Now, when we talk about the phenomenon of refraction, this will be the path of incident ray. See the diagram. This is the path of incident ray, and this is your emergent ray. See. So please remember this particular point. This is very important for all competitive examination. That is, incident ray and emergent ray always parallel to each other. Incident ray and emergent ray always parallel to each other. Please remember this point. Now we are going to discuss, let us move to next slide. The question is, which of the following physical quantities remains same during refraction of light? Your options are wavelength, velocity, frequency, all of these. Tell me, what should be the answer? Which of the physical quantity which remains same during refraction of light? Which of the following physical quantity remains same during refraction of light? Your answer should be frequency remains same during refraction of light. Frequency remains constant, but wavelength and velocity of light will change during refraction of light. I hope it is clear. So just remember, Saurabh Patil, MSc Biotech, is saying A should be the right option. Sorry, C should be the right option. Absolutely correct. Very good. Very good. So please share the session for Kanchan is saying frequency. Very good. Absolute right. Now let us move to next slide, guys. So just remember this point. The frequency unchanged or remains constant during refraction of light, but the wavelength and velocity of light change during refraction of light. Just remember this point. This is very important. Very, very important point for all competitive examination. Okay? Never forget it. So please take the screenshot of this slide. Very, 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 very important slide. So please remember, my dear friends, the frequency unchanged during refraction of light, but wavelength and velocity of light change during refraction of light. Very important point. Now we are going to discuss the very important part of this session, that is laws of refraction. We have two laws. The first law says that incident ray, this is your incident ray, and this is the normal on the surface of glass slab, and this is the refracted ray. This is the incident ray, this is the normal, and this is your refracted ray. All lie in same plane. This is the first law of refraction of light. Incident ray, normal, and refracted ray all lie in the same plane. The second law is known as Snell's law. Second law of refraction of light is also known as what? Snell's law. See, this is the statement of Snell's law. Please remember. Snell's law says that the sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is always a constant quantity, which is known as refractive index of second medium with respect to first medium. Let me explain with the help of a diagram, or you can say example. Suppose this is the glass slab. So this is the air first medium and glass will be the second medium. This is your glass. Suppose light ray goes from air to glass. So this is incident ray, this is the normal, and this is your refracted ray. What is angle of incidence? I, and this is your angle of refraction. Suppose light ray goes from air to glass, and suppose angle of incidence is 37 degrees. Suppose, and angle of refraction is 25 degree. So Snell's law says that the ratio of sine of angle of incidence to the sine of angle of refraction is always a constant quantity, which is known as refractive index of second medium with respect to first medium. Okay? Suppose the angle of incidence is 37 degree and suppose angle of refraction is 25 degree. So when we take sine 37 upon sine 25, it will be, suppose its value is 1.5. So for a given pair of medium, this quantity will be a constant. Suppose this quantity is 1.5. This 1.5, this constant quantity is known as refractive index of second medium with respect to first medium. Here second medium is glass, first medium is air. So this 1.5, which is a constant quantity, is known as refractive index of glass with respect to what? Air. This is the Snell's law. So here 1 and 2 is known as what? Refractive index of second medium with respect to first medium. First medium. Refractive index is usually denoted by n or mu. N or mu. Okay? Is it clear or not? So this is the Snell's law. Snell's law says that the ratio of sine of angle of incidence to the sine of angle of refraction is always a constant quantity, which is known as refractive index of second medium with respect to first medium. Okay. Now what is refractive index? What is refractive index? What is the actual meaning of refractive index? So before going to discuss the actual meaning of refractive index, tell me what is the unit of refractive index? Tell me the SI unit of refractive index. What will be the SI unit of refractive index? Tell me guys. Very important question. And this question has been asked in various competitive examination a lot of time. What is the unit of refractive index? So refractive index has no unit. No unit. Because it is a ratio of same physical quantity. Okay? हाँ बिल्कुल YouTube पर भी क्लासेस कंटिन्यू रहेंगी परवीन, बिल्कुल YouTube पे भी हम लोग क्लासेस को कंटिन्यू करेंगे. So what is refractive index? So refractive index tell us about two things. Refractive index tell us about optical density of a medium and light bending ability of that medium. That is, refractive index is directly proportional to optical density and refractive index is directly proportional to light bending ability of that medium. Suppose we have two media. This is medium A and this is medium B. Suppose refractive index of medium A is 1.5 and refractive index of medium B is 2.4. Now the question is, which of the following medium is denser and which of the following medium is rarer? Which medium is optically denser and which medium is optically rarer? Here we have the relation. Refractive index is directly proportional to optical density. If refractive index is more, medium will be denser. If refractive index is less, medium will be rarer. If refractive index is more, the medium will bend light more. If refractive index is less, medium will bend light less. So refractive index of a medium tells us about two things. Refractive index tells us about optical density of that medium and about light bending ability of that medium. So which one is denser? Suppose we have two media and refractive indices of media are given. The first medium, which is A, refractive index is 1.5, and second medium is B, refractive index is 2.4. Which one is denser? Yes, definitely the medium B will be the denser and medium A will be the rarer. With respect to this medium will be rarer. Now the next question, which of the following medium will bend the light more? Definitely here bending of light takes place, more bending of light takes place, and this medium will bend the light less. Now next question, in which medium velocity of light will be more? In which medium velocity of light will be more? Medium A or B? Tell me. In which medium velocity of light will be more? So in denser medium, light will travel with slower speed, so velocity of light is less in rarer medium and velocity of light is more in denser medium. Okay, तो अगर रिफ्रैक्टिव इंडेक्स गिवन है दो मीडियम का तो उससे हम तीन बातें पता कर सकते हैं. विच वन इज डेंसर, विच वन इज रेयरर, विच ऑफ द फॉलोइंग मीडियम bends the light more and which will bend the light less, and speed of light, refractive index also indicates about the speed of light. If medium is denser, speed of light will be less. If medium is rarer, speed of light will be more. So what is rarer medium? The medium in which speed of light is more is known as rarer medium, and the medium in which speed of light is less is known as what? Denser medium. Okay. Here we have the refractive index of some medium, that is for air refractive index is 1. When we talk about the air and water, which one will be denser? Here water is denser and air is rarer, because refractive index of water is more than air. But when we talk about water and glass, refractive index of water is 1.3 and refractive index of glass is what? 1.5. Here water will be the rarer and glass will be the denser. When we compare these two media, that is glass and diamond, refractive index of glass is 1.5 and refractive index of diamond is what? 2.4. Which one is denser? Definitely diamond will be the denser and glass will be the rarer. Glass will be the rarer. राजबीर इज सेइंग सर एक शायरी हो जाए. इंग्लिश मीडियम में कैसे शायरी करें? ये साउथ इंडियन बच्चों के लिए बैच है, मजबूरी है. ओके, उनको शेर समझ में नहीं आएंगे. ओके, so when we talk about the refractive index of glass is 1.5, what does it mean? Refractive index of glass is 1.5. What does it mean? It means that the speed of light in glass is 1.5 times slower than the speed of light in air, or you can say vacuum. This is the actual meaning of refractive index. And you can find out the refractive index of two medium by using Snell's law. First of all, you have to calculate angle of incidence, then you have to calculate angle of refraction. Then when we take the sine ratio of sine of angle of incidence to the sine of angle of refraction, it will be a constant quantity which is called refractive index of second medium with respect to first medium. Okay. Now, here we have a question. Please try to answer this question. Very simple question. You are given three media A, B and C. of refractive index 1.33, 1.65, 1.46. Okay. Now the question is the medium in which the light will travel fastest. In which medium the speed of light will be more? This is the question. Tell me. Suppose we have three media A, B and C. Refractive index of A is, according to question, 1.33. Okay. Now the B is 1.65 and the C is what? 1.46. Now the question is the medium in which the light will travel fastest. Okay. So which one is rarer medium? See, this is the rarer medium. This is the rarer medium. In rarer medium, the speed of light will be more. So your answer should be option number 1 definitely. Keep it up. Very good. So almost all students are saying the medium which have refractive index 1.33 will be the rarer. So speed will be more. Absolutely correct. Very good. Very good, Kanchan. Rajveer. Very good. Keep it up. Now, let us move to next slide. If you want to calculate the refractive index of a medium, then you can use Snell's law, and here we have another way to find out the refractive index of a medium. We have another formula. The first formula is sin I upon sin R is equal to 1 and 2. Okay. But you can also calculate the refractive index of a medium by using this formula. The formula is refractive index will be equal to speed of light in air or vacuum upon speed of light in a medium. Let me explain with the help of a diagram. Suppose this is a glass slab, okay, placed in air. So this is the first medium and this is the second medium, which is your glass, and this is the normal on the surface of the glass slab. Suppose light ray goes from air to glass. So refraction of light takes place because speed of light changes when it goes from one medium to another medium, that is air to glass. So bending of light takes place, and this bending is called refraction of light actually. Now if you find out the refractive index of glass with respect to air, then what is the formula? If you want to find out the refractive index of glass with respect to air, use this formula, that is refractive index of glass will be equal to velocity of light in air or vacuum upon velocity of light in medium. Here medium is what? Glass. That is velocity of light in glass. As we all know that speed of light in air or vacuum is what? 3 into 10 to the power 8 meter per second. And velocity of light in glass is 2 into 10 to the power 8 meter per second. So tell me, what should be the refractive index of glass with respect to air? Refractive index of glass, that is Ng, will be equal to velocity of light in air or vacuum upon velocity of light in that medium, that is here medium is glass. So refractive index of glass with respect to air will be 3 into 10 to the power 8 meter per second upon 2 into 10 to the power 8 meter per second. Meter per second cancelled out. So refractive index has no unit. Okay. So refractive index of glass with respect to air will be 1.5. 1.5 will be the right answer, Prashant, NDA cadet. Absolute right. Speed of light in vacuum upon speed of light in a medium will give you the refractive index of that medium. Is it clear or not? So please remember this formula. Okay. Now, please try to answer this question. The refractive index of water is 1.33. The speed of light in water will be. Please try to solve this question. Says that the refractive index of water is 1.33. Okay. The speed of light in water will be. Speed of light in water will be. As we all know that refractive index of water will be velocity of light in air or vacuum upon velocity of light in water. Okay. So the velocity of light in water will be what? C upon NW. You all know that. What is C? Speed of light in air or vacuum, 3 into 10 to the power 8 meter per second upon here NW, that is refractive index of water, given in question 1.3. Tell me which one should be the right answer. (2.26 into 10 to the power 8 meter per second will be the right answer. Absolutely correct. Very good. Keep it up, Kanchan. Absolutely right. Very good. Very good, my dear friends. Okay. So please remember. Now we are going to discuss some important points. Then we will discuss the critical angle, total internal reflection, and phenomena due to total internal reflection. Okay. We will also discuss the refraction through lenses also. Okay. Now the first point is, please remember, when a light ray goes from rarer medium to denser medium, here first medium is air and second medium is glass. Which one is rarer? Refractive index of air is 1 and refractive index of glass is 1.5. So which one is rarer? This is the rarer medium and this is the denser medium. So when a light ray goes from rarer medium to denser medium, speed of light will decrease or increase? Speed of light will decrease. So it will travel a lesser distance, so it will bend towards the normal. So when a light ray goes from rarer medium to denser medium, it bends towards the normal. In this situation, which one is more, I or R? Tell me. This is your I and this is your R. So when a light ray goes from rarer medium to denser medium, okay, rarer medium to denser medium, it bends towards the normal because speed of light will decrease. And in this situation, I will be more than R. Angle of incidence will be more than angle of refraction. Please remember this point. Okay, this is your I and this is your R. Now the reverse situation is when a light ray goes from denser medium to rarer medium. This is the second case. When a light ray goes from denser medium to rarer medium, suppose this is air and this is glass. Okay. Denser, which one is denser? Glass is denser. So it bends away from the normal. Here speed of light is 2 into 10 to the power 8 meter per second, and in air 3 into 10 to the power 8 meter per second. So when a light ray goes from denser to rarer, it bends away from the normal. In this situation, which will be more? Which angle will be more, I or R? So this is your I, this is angle of incidence, this is the incident ray, so this will be I, and this is refracted ray, so this will be R. So which one is more? So when a light ray goes from denser to rarer medium, I less than R. Please remember. So when I less than R, what does it mean? Light is traveling from denser medium to what? Rarer medium. And the third is very important. Third point is very important. When the light incident normally on a glass slab, it will goes straight. there is no refraction of light will occur. Okay. So, when a light ray incident normally on a glass slab, it will goes straight, there is no refraction of light because I is 0, so R will be also 0 from Snell's law. Is it clear? If clear, please comment clear sir. If you have still any doubt, you can ask please. Away from the normal, very good. Now, so please remember these 3 situations, very very important. Okay. ये हैंग कर रहा है. हो गया लगता है. Okay. So please remember, when a light ray goes from rarer to denser, it bends towards the normal. Here I more than R. I will be more than R. Okay. This is I and this is your R. When a light ray goes from denser to rarer medium, it bends away from the normal, here I less than R. And when a light ray incident normally on a glass slab, there is no refraction of light takes place. It will go straight. Okay. Now please try to answer this question. A ray of light passes from a medium X to another medium Y. Okay. Suppose I am showing the situation. See. Look at the diagram, guys. Suppose this is the medium X and this is the medium Y. Read the question carefully, then answer. A ray of light passes from a medium X to another medium Y. No refraction of light will occur. Okay. No refraction of light takes place. If ray of light hits the boundary of the medium Y at an angle of, condition is a ray of light passing from X to Y, medium X to Y, and no refraction of light takes place if ray of light hits the boundary of medium Y at an angle of, tell me the angle. Very tricky question. Yes, the angle will be what? 90 degree. Yes, absolutely correct. So right answer should be B. So when a ray of light hits the boundary of a medium at an angle of 90 degree, there is no refraction of light takes place because angle of incidence is I. Suppose this is the angle of this is the incident ray, and angle of in this situation an angle of incidence will be 0. What is the angle of incidence? This is the normal and incident ray. So angle between normal and incident ray is called I. So when a light ray incident normally on a glass slab, in this situation I will be 0, so R will be 0. I hope it is clear. Okay. So right answer should be B. Very important. Very good. Very good. Deepak, Kanchan, Prashant. Absolutely right. Now we are going to discuss phenomena due to refraction of light. Very, very, very important. Okay. Suppose if the question is partially immersed stick or pencil in water appears to be bent due to refraction of light. Okay. Reflection of light. Due to total internal reflection of light and dispersion of light. Tell me the answer of this question. What will be your answer? Partially immersed stick or pencil in water appears to be bent due to, your answer should be refraction of light. An object placed under water appears to be raised due to, again your answer should be refraction of light. A swimming pool appears to be less deep than the actual depth due to what? Refraction of light. When a thick glass slab is placed on some printed matter, the latter appears to be raised due to, again your answer should be refraction of light. Can you give me some more examples of refraction of light, that is phenomenon due to refraction of light? Tell me some more examples, guys. These all phenomena take place due to refraction of light. Partially immersed pencil in water appears to be bent, है ना? An object placed under water appears to be raised. Now we are going to discuss some more examples. See, a lemon kept in water in a glass appears to be bigger than actual size due to refraction of light. When a coin is placed under water, coin appears to be raised due to refraction of light. A fish underwater appears to be shallower than its actual depth due to refraction of light. So please remember these all examples, these all points. Okay, Kanchan is saying a lemon kept in water appears to be bigger than the actual size. Absolutely correct. Very good. Very good. Keep it up. Okay, so please remember these all points. 1, 2, 3, 4, 5, 6 and 7. Okay. So a swimming pool appears to be less deep than actual depth. When we see, suppose this is the water surface and suppose this is the swimming pool. When we see, then swimming pool will appear less deep than actual depth. So this depth is known as apparent depth, and this will be your real depth. So please remember a formula. Refractive index is equal to real depth upon apparent depth. Refractive index will be equal to real depth upon apparent depth. This is the real depth and this is the apparent depth. Please try to answer a simple numerical problem. A fish at the bottom of a pond appears to be 1.2 meter from the water surface. Okay. Question says that a fish at the bottom of a pond appears to be 1.2 meter. Appears to be 1.2 meter from the surface of the water. 1.2 meter. So this will be your apparent depth. Calculate real depth. Calculate real depth. If refractive index of water is 1.33, so please use this formula. N is equal to real depth upon apparent depth. Just remember, just use this formula. N is equal to real depth upon apparent depth. Tell me what will be the answer. N is equal to R upon A. Refractive index of water is 1.33 given in the question. Real depth upon apparent depth. Apparent depth is given 1.2. So real depth will be 1.33 into 1.2. This will be your answer. So right answer should be 1.6 meter. Absolutely right. Very good. Keep it up. 1.6 meter. This is the solution of this question. Okay. So these all phenomena are due to refraction of light. Pencil appears to be bent. Okay. A lemon appears bigger in size. Now what is atmospheric refraction? Now we are going to discuss atmospheric refraction of light. What is atmospheric refraction? So we will discuss atmospheric refraction in next session, guys. This is very important. Then we will discuss total internal reflection of light, critical angle, refraction through lenses, lens formula, power of lenses. Then we will also discuss some optical instruments. Okay. तो आज के लिए इतना ही रहने देते हैं, मिलते हैं अगले सेशन में. कोई डाउट है तो आप पूछ सकते हैं. इफ़ यू हैव स्टिल एनी डाउट यू कैन आस्क प्लीज़.